Good morning, my YouTube viewers. In this particular video, what we're going to be doing is we're going to be covering a paired t-test. And this is going to be a practice question concerning a diet plan. So do you want to evaluate the effectiveness of a new diet plan? You collect the weights of 15% participants before and after following the diet for 3 months. Test whether the diet plan had a significant effect on the participants' weights with a 5% significance level. So we're going to answer this question using Python. And in order to execute the program, what we need to do is we need to import 3 libraries. So we're going to import NumPy as NP, which is the numeric library. And we're going to import SciPy.stats as stats, which is the statistical module in the SciPy library. And the SciPy library is a scientific library. And we're going to import matplotlib.pyplot as PLT, which is the visualization library. So we want to generate the sample data. So in order to generate the sample data, the first thing that we need to do is we need to set our seed. And so what happens when we set the seed is every time we run the program, it'll start up with the same initial values. So in order to set the seed up, you type np.random.seed, and you can put any number you want in the brackets. So now we set up the random data for before the weights and after the weights. So before weights equals np.random.normal, brackets, log equals 70, so that's your mean equals 70, scale equals 5, that's your standard deviation, and size equals 15, that's the sample size. And then after weights equals before weights minus np.random.normal, log equals 3, that's your mean, scale equals 1, that's your standard deviation, and size equals 15. So we're going to assume an average weight loss of 3 kilograms. So we're going to perform a paired sample t-test. So t statistic, p-value equals stats.t-test underscore rel, brackets, before weights, after weights. So this is a paired sample t-test. The difference between a paired sample t-test and a 2-sample t-test is a 2-sample t-test, the values are independent of each other. But in a paired sample t-test, the values are dependent. So you need to make sure that you use the correct test. And since this particular test concerns you're checking the weights of people before and after the diet, it's going to be a paired sample t-test. So we're going to print the results. We're going to print the t statistic and the p-value. So the t statistic is 13.1 and the p-value is 0. And so since the p-value is 0, then that means it is less than the alpha. So you're going to reject the null hypothesis. The diet plan had a significant effect on the participants' weight because the participants lost an average of 3 kilograms. And so you can see on the graph that's been made, you can see the before the diet is blue and after the diet is red. And you can see that they lost 3 kilograms in 3 months, which is great news. So now we've already interpreted the result. The alpha is 0.05. If the p-value is less than alpha, you reject the null hypothesis. The diet plan had a significant effect on the participants' weight. So that's what we did. We rejected the null hypothesis because the p-value is 0 and it is less than the alpha. So now what we're going to do is we're going to plot the weights on a graph. So plt.figure, brackets, fig size equals 6, 4. So PLT.plot, brackets before weights, comma, label equals before diet, comma, marker equals 0, comma, line style equals dash, comma, color equals blue. And then PLT.plot, brackets, after weights, comma, label equals after diet, comma, marker equals 0, comma, line style equals dash, comma, color equals red. So X label is participant, Y label is weight, and the title is weights before and after diet. So you've got a legend and a grid, and you're going to show the graph, show the chart. So you've got the weights before and after the diet. And then so basically we could change it. We could change the average weight loss to like maybe say 1 kilogram, and that might accept the null hypothesis, because the if we change the weight to 1 kilogram, it could accept the null hypothesis. So so your mean is 3, your scale is 1, and your size is 15. So if we change our mean to 1, and then we bring it down here, it says your p-value is 0.0086, so it rejects the null hypothesis. The diet plan had a significant effect on the participants' weights, but even though it was 1, you still had a p-value of 0.86. So, try that. So the p-value of 0.0748 says failed to reject the null hypothesis. The diet did not have a significant effect on the participants' weight. So because I set the mean up as being 0, and because I set the mean up as being 0, it failed to reject the null hypothesis. But now we'll set the mean back to 3, which was the original question, and it's reject the null hypothesis. So that's how you do it in checking the male and the female weights. So this concludes our video. The next video we will be covering another sample test on hypothesis testing. So thank you for watching this video, and I look forward to seeing you in the next video.